All right, everybody. Let me do, yeah, there we go. Okay, good morning to all of you guys. I hope you guys are doing well. Let's see who's here, who's at home. Good morning, Steve. Good morning to you. Panawa, good morning. Let's see here. Blanca Hernandez, good morning to you. And Hector Lopez, good morning. Good morning to everybody here. I just want to let you guys know that, you'll be getting your test back today. I've graded it and I'll be returning it to you. Stop by in office hours if you haven't gotten your first test back. You guys should get your tests back. We do have this flexibility, of being able to stream from campus, and you can enjoy the course at home or in person. But if you think you do better in person, by all means, be here in person. That's what it's for. Anyway, okay, so I'll be giving back your test. And also, since we're giving back your test, you're kind of starting this iteration over. This class can be very simple, but you need to be engaged and you need to be consistent with what you do. Like, you're doing your homework every day. You don't wait till the weekend before, the night before. If you do that kind of stuff, it ain't going to happen. And the sad thing about students who do that, they draw the wrong conclusions. They think they can't do mathematics or trigonometry in this case, when they really can. They just never put themselves in the position to be successful. And that's really the end of that's really the story. If you guys want to know, that's completely the story. Now, you say, how do you know all these details? Well, aside from teaching mathematics for probably, I hate to say it, around 30 years now, okay? I've seen it, but I also used to do it. So that's how I know, okay? So it's doable. It's just a matter of, how are you approaching what you do? Do you approach it successfully or do you approach it unsuccessfully? It's just the approach. Okay? So take a look, ladies and gentlemen. I'm going to introduce you to a very powerful tool in trigonometry. And this is a tool that we'll be using. So a lot of times, if anybody ever says, hey, are you taking the trig course? Yes, they expect you to know this kind of information. This is called the law of sines. Now, I'm going to put, very often you put these letters to represent the angles or the vertices. And they'll use this, I think your text uses it this way, which is kind of like a counterclockwise ABC. So A, B, and C here, these are really your angles. Okay? So they're capital letters, and they represent what we call, they're called vertices, but they're the interior angles. They just have letters like A, B, and C. Now, the sides opposite those letters, like the big A, we call that little a. So that's the side. It's opposite. Okay, this is just a convention they use. You guys want to think about that. So if the vertex is big B, the side is little b, and then this is little c. And ladies and gentlemen, this here is a what? Triangle. Okay? Let me get my water since I'm panicking. Let's get some water to get this dry cough. And can never figure out how to open a bag with 20 zippers. Hey, these aren't my favorite barbecue chips. What the hell? Got a sandwich. Let's double check. Did they take our masks? No. Is that anybody's orange juice? Oh, it's yours? Oh, okay. I thought it was left over night or something. You imagine? Anyway. open the box. There you go. So we don't scare people coughing, you know. Like all that, Mr. Judge. Okay. Now, here's the deal. You guys remember this? I'm going to do something here. I'm going to remind you guys. If I say to you, remember our area formula? Remember, the area formula A, remember this, that was based on a very important idea. I said it's based on this criteria of side, angle, side. Side, angle, side. And in this case here, you had this, like if we put that theta there. Do you guys remember this? So I gave you guys this formula, 1/2. Now, in terms of the angle theta, right? What does side, angle, side actually mean? What do you need? You need a side, you need two sides, and the angle's between two sides. So I want you guys to start to understand something important here. That the angle is what? Between two sides. That's an important detail. It's called side, angle, side for a triangle. This is not a right triangle, ladies and gentlemen. This is a general triangle. It's not a right triangle. And so what was the formula? Do you guys remember? If you had an angle theta, what do we say that area formula was? Wasn't that going to be, in this case, BC sine theta? Okay, you guys get my point here? And you said, but Mr. Judge, we're not using theta. What are we using? A. So theta here is the same as angle A. You guys okay with that? So you're looking at the area formula that I derived for you guys last time, okay? You guys okay with that? Now, there's nothing unique about the angle A. We could do this. We can say, what if the angle was over here? Okay? Now, angle, side, angle is what we see in red now. Okay? You have an angle between two sides. Does everybody agree with that? So I can apply the area formula, and the area formula is going to be 1/2 AC sine what? B. Because now this is your angle, sine B. Okay, and so now you go over here. You go, okay, what about this over here now, right? You say, let's move this angle here. There's your angle. Now, that now means your sides are A and B. Is that true? And that's for angle what? C now. So you can apply the area formula again. And if you do, you get now what? Area is 1/2. What are the sides? A and B. And that's now sine C. 1/2 AB sine C. Is everybody okay with that? So I just want to point out to you, you want to really start to understand that when you're dealing with some of these triangles, the sides and the angles have relationships with one another, and we're going to focus on that. It's not a bad thing. So, okay. Now, since this area, is all the same, that inside area. What this means is, ladies and gentlemen, this relationship that we just seen here, and I'm going to have to move this. This means 1/2 AB sine A is the same as 1/2 AC sine B, which is the same as 1/2 AB sine C. Okay, because the area is the same. In other words, all of these equations are equal to one another. Do you guys agree with that? And then I'm going to say to you, okay, another thing. I can divide the left side of, since these are equalities, these are equations, I can divide the left, the right, and the middle by 1/2. Is that true? So if I said to you, I'm going to divide everything by 1/2, and you say, why, Mr. Judge, you divide them by 1/2? So I know that this goes away and it cancels. Okay, you guys okay with that? So all I did was divide everything by 1/2. Okay, so that means that this portion is gone. So I want you guys to understand that here. This is still all equality. Now here's the key. I'm not just really going to divide by 1/2. I'm going to divide everything by a non-zero number called ABC. I'm going to divide the left, the middle, and the right by ABC. I can do that since these are like proportions or equations. They're all equal to each other, so they're the same. Let's close that door. And I notice a typo. This should be what? BC. So I noticed that this term should be BC. I apologize to you guys. Fix that in your notes. Let's double check BC, AC, and AB. Now we're good. Okay? So ABC is a non-zero number. Remember what ABC is the sides. It's all of these sides here, ABC, right? So they're not zero when you multiply. They're actually positive. Anyway, okay. Now let's do cancellation. What do you guys see canceling here, right? Your BCs go away. Your AC goes away, A and C. Your AB goes away. Now what you have left here is the following. You have what? Sine A over little a is sine B over little b, which is sine C over little c. And so, ladies and gentlemen, what you are looking at is a relationship called the law of what? Sines. Okay? And if you're going to get a tattoo on a drunken weekend and you're taking trig, I would say, hey, consider this one because it's a very useful, very, very useful tattoo. In other words, you might say, what do you use this for? Why do we care? Because we can do what with this? We can solve various triangles with this. That's why you care. Because we can solve some triangles, not every triangle with it, you'll see. But this is a method of solving some triangles. Okay, now you say, which triangles can we solve? Well, we can start by solving, I want blue, angle, side angle triangles. We're going to have to categorize what we see. We also have side angle triangles that we're going to see. And side angle triangles that we can see. So this is thought of as really using cases. And this is where we're going to start with this very famous angle, side angle triangle situation. So this is our starting point. You guys okay with that? So anytime that we have an angle, side angle triangle and we have to solve it, we are going to use the law of what? Sines. Okay, now pay attention to this important detail. This is how I can remember this. This is angle A and this is side A. Do you guys agree with that? And then notice this. This is angle B and this is side B, the opposite angle to B. It's all in these pictures. So what I'm remarking about, if I remove this stuff, A, A, B, B. And now you have C here. Angle C, side C. So you have this C here. Okay? That's what I want you guys to start to consider when you look at this formula here, because you're going to see how we use it. Okay? You guys okay with that? Anyway, all right. Now, here's what I'm going to do. I'm going to go to, I have a worksheet online. And if I go to the browser and you go to Trig, there we are. We have something called, what over here? Law of what? Sines. I'm going to put that here. And we're going to use this kind of like as the first example, but I'm going to bring this all for us. Demonstrate how you use it. Copy that. I have that same sheet here. Okay? Now, you might say you can't see what I have. And I'm going to try to get rid of, I don't think I need this, this, and this. Okay. Now, you might say, why do you have law of sines, law of cosines? Well, that's for the other triangles. This whole worksheet's for law of sines and law of cosines. But our focus in the beginning here is law of what? Sines. And in fact, notice the vertices. A, what? B, and C. And notice this. You say, what do I have to notice? Angle, side, what? Angle. So this is an angle, side, angle situation. And that's what we want to know. That's what tells us what to do. If it's an angle, side, angle, what do you use? Law of what? Sines. Okay, now let me demonstrate to you guys how to use it. You guys ready? Take a look. I'm not going to go through the detail like this for everyone. Why do I call that little a? It's opposite angle A. Good. Why do they call this little b? Opposite B. Yeah. So when you color this, you go, oh, are you referring to this? Yes. Are you making that reference? Absolutely, ladies and gentlemen. And purple. Purple. There you go. So you might say, how do we use this? Pay attention to something here, okay? Notice this. If I look at, let me look at, for example, let me just look at this without looking at the triangle. You want to know what makes this all work? What are you looking at here? This is called a what? Proportion. And for proportion, what do you have? You got 1, 2, 3. You got 4 quantities to consider. 4. And in order to solve any proportion here, don't you need what? You got to know, you have to have 3 of those quantities known, is what I'm saying. 3 quantities need to be known in order for you to get the 4th quantity. So I see 4, and you say, well, what about the other one? Well, still, in this proportion, right, you still have 4 quantities. You need to know 3. And if you say, what about if I use this other one? Well, there's another proportion you'll see. You go, what are you talking about? Well, sine A, over A equals sine C over C. You create a proportion. Again, 4 quantities, you need to know 3 in order to get the 4th. And that's the idea. It goes back to the concept of proportions and cross multiplying. We've done a lot of that in the S portion. Do you guys agree? So this is what I'm saying. If you could work with a proportion by cross multiplication, and then use a calculator, well, then you could do trig. But it's not going to happen overnight. You can't look at it the night before and go, okay, I'm going to try it now, and everything's going to work out for me. If you do that, I guarantee it won't. I guarantee it. Okay? So, ladies and gentlemen, that's the whole idea behind using this. Let's look at the particulars now, right? So, if I go back, and we have to get rid of this color because it starts to distract me. Let's see how to use it. All of that just to try to talk about what? How to use this. All right, well, it's important. Okay. What do I know? Huh? Yeah, angle A is 42 degrees, angle B is 50 degrees, and then angle C is what? Another 50 degrees. I have a problem, ladies and gentlemen. What do you think I should always do first? If you're in angle side angle first, I'm going to point this out to you. Find angle C. How do I know angle C? I don't know. The sum of the interior angles is always what? 180. So you take the 180 minus the what? 42 degrees minus the 50 degrees. So get this angle first, okay? For angle side angle. And if you said, well, how do I do that? Well, use some arithmetic. Right? 180 minus 92. Is that 88 degrees? Do you guys know what I'm saying? Double check. I only had 2 cups of coffee, and that might not be enough. Remember? 180 minus 42 minus what? 50, and what does that give you? 88 degrees, ladies and gentlemen. Okay? So you say, why is that? Again, well, go back. In case you guys don't recall, I want you to note, this is an important note, that if you add angle A, and sometimes we put angle A, angle B, plus angle C, what should that equal? 180, a straight line. And that's the sum of the interior angles for any triangle is 180 from geometry. So this is what you guys want to use. Now you say, why is that so important? You guys know why it's so important? Because you couldn't even use law of sines without that angle. So I was looking at this and go, hey, wait a minute. Yes, we're supposed to solve a triangle, right? So we have the angle anyway. That's your first step. And then you say, how do I use law of sines? Well, notice this. Isn't it true that sine of 88 degrees over what? 50. Okay. In other words, I know an angle and an opposite side. That is a good thing. I now have a choice. Do I want to find little a or little b? Doesn't matter. Sine of 42, little a. So this is equal to sine of 42 degrees over little a. Okay? I can now find little a. You guys okay with that? You guys know what I'm saying? And then if you said, well, what about little b? What if I chose to find little b? Well, you got sine of 88 degrees over 50 is the same now as, what is this here? I'm going to use a different color. Sine of 50 over little b. Okay? Sine of 50 over little b. Now, what do you guys use? Anybody know since you have proportions? Cross, good. You're going to cross multiply. Like you've been doing repeatedly in this course, using ratios. This is why ratios and proportions are a very fundamental tool that's extremely important to a lot of concepts in math and science. And in pharmacy, if you guys want to know the truth. All right, you guys okay with that? There it is. So what does that mean? Do you guys know what that means? I guess I'll go through every detail. That means sine of 88 degrees equals what? 50 sine of 42 degrees. And then divide both sides by sine of 88. What happens? A becomes 50 sine of 42 degrees divided by sine of what? 88 degrees. Okay, so what do you think happens now? This is where you get out your calculator. Okay, so we take 50 times sine 42 degrees divided by sine of what? 88 degrees. And we can approximate to the tenths. And what does that give you guys? You guys know? A is approximately what? 33.5. Is that true? You guys see that there? A is 33.5. So you go back and you go, well, what is A? We can now replace this and say this is what? 33 point what? 33.5. That's little a. That's the length of that side. So far, so good. Easy breezy, lemon squeezy. Solving proportions, ladies and gentlemen, is, like I said, you can do a lot with that. And then if I go back here, and I'm going to erase this. I apologize. You guys have a video. The reason videos are great is you could go back and rewind. Is that right? At least that's what some of my students tell me. They go, I like that because I could rewind. Okay. So let's cross multiply. What do you get? B. Sine 88 degrees is going to be 50. Sine 50 degrees. Divide both sides now by sine 88. What does that give you? 50 sine 50 degrees over sine 88 degrees. What does little b become, ladies and gentlemen? Let's go to the TI. All this by cross multiplying. 50 times sine of 50, close that, divided by sine of what? 88. What do you get? 38 point what? Is that 38.3? And ladies and gentlemen, 38.3, that's little b. So what are you guys looking at here? You're looking at the fact that we have every angle, every interior angle, and every side. That's called solving a triangle. It's a non-right triangle, right? And that's the idea. The generalization of that idea is to use law of sines and eventually law of cosines, because what you can see is very different. Okay? You're not always given angle, side, angle, so you're going to have to take cases. And that's good, ladies and gentlemen. And there you go. I can now go home and go take a nap. Not really. Who can sleep at home? Maybe you guys, you're young. You could sleep at home. Is that right? Still. You become old, and what happens? You can't sleep at home so easily. Being at home is better than being at work. At least you get something done. That's why maybe being face-to-face is a good option for some people. Because being at home is what? It's too comfortable. You guys know what I'm saying? So we're the bonbon crew. We got at least 4 people at home with eating bonbons, and then some other students watch videos later. Once they get up, you guys know what I mean? So being at home might be too comfortable. You might have to get, you might have to wake up in the morning and shave, shower. You know what I mean? Get out of that comfort zone, start your day, and maybe make your bed. Okay? You say, no, don't make the bed. Watch, neither do I, but don't tell anybody, but I give everybody that advice. You know what I mean? You say, why? Because you complete a task. I've been told completing that first task every morning, something simple like making your bed, is important for some people. I mean, it's crazy. Well, I don't say it's crazy. It sounds crazy, but it's not. Something simple like making a bed, you completed the task in the morning. For me, you say, what's my first task? I complete shaving for me. You're not going to see Mr. Judge not shaved, you know what I mean? And then taking a shower, another task. Getting dressed, another task. Drinking your coffee, another task. So we complete these tasks. Anybody know who Magic Johnson is? You know what the first thing he does before he makes his bed and anything else? You know what the first thing he used to do? Was shoot free throws. He used to shoot 100 free throws as soon as he woke up. What happened if he did that every day? He became very good at free throws. What do you think would happen if he woke up every morning and did some math questions? How good do you think you'd be? You'd be phenomenal. Because this is what this is about. This is about practicing and doing that work. Okay? I guarantee you. Now, is this an side angle situation? You say, how do I know? Angle, side, what? Angle. I actually encourage you guys to write that down. Because once I write that down, you know what that tells me I use? I have to use what? Law of sines. Now, we notice you got two angles again. How do we get that third angle? Because that's the first thing you guys do. Right? You guys remember? You take the 180, you subtract the 58 degrees, and you subtract 62 degrees. So you subtract these. And what do you get now? You get what? 180 minus 58 minus 62. And what do you end up with? You now know that this angle is really what? 60 degrees. Okay, you guys okay with that? Now, this is little c, this is little b. What do you think I'm going to use now, ladies and gentlemen? We're going to say what? Sine of 60 over 25. Is that true? Sine of 60 over 25. What does that equal to? We can say sine of what? 62 over little b, and we can also say sine of what? 58 over little c. So if you put it all this way, it's not the more practical form. Here's what I mean. Although that's true, this is the law of sines. I would say set sine of 60 over 25 equal to sine of what? 58 over what? Little c. Okay? And then you can cross what? Multiply. And there it is. You can solve now. Notice what you can solve for. Little b and little c. Because you have three quantities that are known and one unknown. You always can do that then. Okay. You guys know what you end up getting? B sine 60 is 25 sine 62. And then what does that mean about little b? B is going to be 25 sine 62 degrees over sine what? 60. So what does little b give you now? Okay, go to the calculator. 25 times sine 62 divided by sine what? 60. And what do you get? 25 point what? 5. And ladies and gentlemen, there you go. 25.5. And you say, well, what about the next one? Well, do the same. When you cross multiply, you get what? C sine 60 degrees becomes 25 sine 58 degrees. Divide both sides by sine 60, and you get C 25 sine 58 degrees over sine of 60 degrees. So you're now going to get little c, ladies and gentlemen. So go to the TI, and you say, okay, 25 sine 58 divided by sine of what? 60. And what does this give you? 24.5. Good job. Good job. So you got B, 25.5, and C, 24.5. Okay? So go back here. And go back here. And notice this, ladies and gentlemen. You now have, you solved the triangle because you have every known what? Angle and every known side. Okay? You got everything that you need. There it is. Is this an angle side angle situation? How many people say yes, it's an angle side angle? Okay, good. How do you know? Angle, side, angle. In other words, is the side between the angle? I'm sorry. Yeah. Is the side between the angle? Yes. So what do you guys use? Law of what? Sines. Okay. I'm going to give you guys a few minutes to try this yourself. And we'll see how this goes. Solve the triangle. All right, ladies and gentlemen. Let's try this out. If we can get there. There we go. Okay. Now, notice what I'm going to do here. I think your book does it this way. It starts ABC. Okay. Now, since you guys already know, we need to use law of sines. Find angle B. 180 minus 32 degrees minus 70 degrees. Is that right? What did you guys get here? 180 minus 102 should be 78 degrees. You are correct. Good job. Okay, you guys okay with that? First step. All right, what do we do with this now, right? What do we get to say? What's the opposite side? Now we get to use sine 78 degrees over 12. That ratio is equal to sine 70 degrees over, I didn't even label that. I will now little c. So I can get little c. This will be little a, right? I can also say sine 78 degrees over 12 will be sine 32 degrees over little a, ladies and gentlemen. Okay? Cross what? Cross multiply. Cross multiply. Okay, is that pretty good? Okay, so we have two equations. See if I can get everything. 1, 2. So this means, so if I do number 1 now, C sine 78 degrees equals 12 sine 70 degrees. And little c becomes 12 sine 70 degrees over sine 78 degrees. Okay, double check. Is that what you got? Okay. So, let's clear this out. 12 sine 70 divided by sine what? 78. What do you get? 11.5. So C is 11.5. So hopefully you guys have 11.5 here. Okay? Good job. Equation number 2, what does that become? Right? A sine 78 degrees is 12 sine 32 degrees. Divide both sides by sine 78, you get 12 sine 32 divided by what? Sine 78. What does little a become now? Right? Double check. Did we do that okay? 12 sine 32 divided by sine of what? 78. What do you get? 6 point what? 5. And there you go. A is 6.5. And what do you guys notice? Did you solve the triangle? Sure did. Easy breezy, lemon squeezy. What do you guys think? Look at the fourth question here. Okay, fourth question. You say, what do I mean by the fourth question? What do you guys have here? This is an angle. Is that true? What is this? Side, side. We call this side, side what? Angle. Okay, notice something here though. If I label that A, B, And C, you might say this is a law of sine situation. And I'll say yes. It's law of sines. Didn't we say out here, when do we use law of sines? Did we say? I thought I did somewhere. Oh, I thought I wrote it down somewhere. Anyway, maybe I said it. Okay. Yeah. Oh, it's in the other note. It's in the other note. Where is that? Right here. There you go. Side, what? Angle. Okay, now let's see. Let's label things here. This is going to be now opposite is little c. Is that true? Okay, let's see why this works. Remember why this works? What do you need? You need 3 known quantities and what? Only 1 unknown. So can I say the following? That sine 32 is over 8. I have the angle on the opposite side. Is that true? And then what else can I say? What's sine of B? It's 10. So this is going to be a little bit different, ladies and gentlemen. Okay. And then notice you say, but Mr. Judge, I'm really in a bad spot here. I got angle C and sides opposite. I got 2 unknowns. Well, don't go there then. Don't go there. Okay, use this ratio. So when we cross multiply, this is how this is a different question. Okay, side angle, you can't start off by getting that angle because you only have 1 angle. You don't have 2. Okay, you need 2 angles to get a third angle. All right. So when you cross multiply, what do you end up getting? Don't you get what? 10 sine 32 degrees, is that right? Over what? 8 equals sine of B. Okay. So what happens now with this? What do you guys think? Here's what I want you guys to get. Get what sine of B is. Sine of B is 10. I'm going to have to write it this way. 32 degrees over what? 8. Okay? All right. Now, let's try this out. 10 times sine of what? 32 divided by 8. And what does this become? Yeah, let's go back over here. Let's say sine of B is approximately, if I go to the nearest tenth, 0.7. Is that right? You guys okay with that? Now, you have an issue. This is a very, very special case. This is a special situation. Oh, there we go. Darn. Okay, this is a special situation, side angle. I want you guys to note for side angle here, okay? We have 3 possibilities. Usually when you teach this topic, you save this to the end. Okay, you have 3 possibilities here. You know what's called one solution. You can have 2 solutions. or you could have no solution. Yesterday, before we had our technical difficulties on the law of sines, okay? Now, I want to go back to our notes. And I want people to know something here, if I can find it. This is oh, there we go. I think this was our notes. Yes. What I want people to do is this. This last situation is a very, like we said, a very special situation, okay? And that's typically reserved as a last set of examples. Okay, I want to say that again. When you teach and study law of sines, and it could be very simple, ladies and gentlemen, you just got to put the time and energy into it. You start with what we started with, angle, side, angle, and then you really go to side, angle, angle. You conclude law of sines with the special situation, okay? So what I want to do is look at examples that here we skipped and went to the conclusion of law of sines, which can be done. It's not technically a problem, but I think what works better is to talk about the side angle angle situation. So this is what we're going to continue to work with, and we will get back to the what? The special situation. Okay, you guys okay with that? So I'm going to look for examples in our worksheet for side angle angle, and really understand what side angle angle is. What does this mean? You essentially have adjacent angles. You say, how do we know they're adjacent? Well, because you have that angle angle part. They're next to each other. And then you have actually one side, in all honesty. Okay, so we're going to look for the adjacent angles and one side and apply law of sines in the way textbooks actually encourage people to do, okay? All right, so if I go back to my worksheet, if I can find that, I think it was just titled, there we go. We're going to get back to you in this problem because it's a great problem, number 4, but we're going to get back to it later. And I need 2 angles. That's not it. It's not it. I need 2 angles. You say, Mr. Judge, who wrote this? I don't know who wrote this. Whoever wrote it did it backwards. Where's our 2 angles? Okay, we're going to have to make it up then. So if it's not here, it isn't here. Oh, yeah. Odd. Whoever did this. I don't know. Okay, let's do it here then. Okay, so we need 2 angles and then a side here. So just to kind of give you a basic illustration of this. Okay, so if they say this is 32 degrees, it doesn't look like it's 32, but it may look closer to 52 degrees. And this is maybe 45 degrees, okay? And then this is maybe 12. So you might say to me, what am I looking at? This is vital for you guys to consider for this, right? It needs to be a what? Side, and then 2 adjacent angles here. 1, 2. Adjacent just meaning next to each other. And so when you identify this, you say, I got the side angle angle situation. This is again a what? Law of sines scenario, okay? Well, that's great. All right, you guys okay with that? Law of sines scenario. Now, you might say, do I approach this the same way? Yes. What do I mean by that? What was the first step with the angle side angle? Get the third angle, absolutely. So you say, okay, this will be 180 degrees minus 52 degrees minus 45 degrees. Okay, you got 180 minus 52 minus 45. So what angle do you see here? Is that 83 degrees? Okay, 83 degrees, ladies and gentlemen. That's your first step. Is that right? So notice we're on our way to solving these triangles. And if you did something like this and say, hey, that's vertice A, vertice B, vertice C, we could now say, oh, that's little c and this is little a, okay? So you can name these things, and that might be good because you're going to use again now the fact that you have a what? An angle and an opposite. Oops. Where is it? Let's change our colors. You're going to use the fact that you have a what? Angle and an opposite side. So I want you guys to see that. You're going to use this because you can say, I have sine 45 degrees divided by 12 will equal, now I'm free. You say, what am I free to do? Well, pick A or C, right? We can say this is now sine 83 degrees over little c. You say, well, I have the C vertice, and I have that's known. The 83 degrees are known, but I don't know little c. So now that opens the door to what? Cross multiplication. You do the same, ladies and gentlemen. You say, what do I do the same with? Let's change the colors. You have 52 degrees in green, and you have A. Little a. So you're going to say now, sine 45 degrees over 12 is actually sine 52 degrees over A. Okay, you guys okay with this? And I'm going to remark, because at this point, what do you guys say we do? What do you do now? I mean, I wrote it down. We have to what? Cross multiply. Is that right? Yeah. Did I put 48? That's sine 45 over 12, and then sine 52 over little a. So what I'm showing people is this is the green. Oh, that's a 45. I'm sorry. It doesn't look like it. It is a 45, but it should be clear. Okay. Yeah. So I'm trying to demonstrate to people this is how you use, what do we do there? It's orange, I guess. This is how we use law of sines. And then purple, you have here. Okay. So just want to kind of illustrate that to folks because now you cross multiply. So we say sine 45 degrees times c is 12 times sine 83 degrees. And now if I divide both sides by sine 45, we get 12 sine 83 divided by sine 45. This is how we get little c. All right, you guys okay with that? And then you might say, okay, well, how do we handle this? I think our TI is woken up. So 12 sine 83 divided by sine 45. And what do you end up with? What is C approximately? 16.8. There we go. Okay, so just kind of pointing out the details. Again, let's do some algebra here. Twelve sine 52 divided by sine of what? 45. And what do you guys notice? What is this? 13 point what? 4, ladies and gentlemen. And there you go. So what do you guys think? Is that easy breezy? Lemon squeezy? I think it's doable. You guys think it's doable? I mean, you can't complain about the math. You go, well, I do want to complain, because the world complains about math, ladies and gentlemen. It's sad. Heartbreaking. You get to use a calculator. Okay, you guys okay with that? Okay, so I'm going to look over your textbook and demonstrate to you guys something here. What if you see a triangle that looks like this? If I can draw. And you have A, you have B, and you have C here. But this here, they're going to do this. This measures 23 degrees. This measures 125 degrees. And this is 15 feet, you know. I know we haven't always put the units, but there you go. This here is little a, this is little b. Does anybody know? Isn't this still a triangle? But what kind of triangle is this? I want you guys to remember here. You see that angle? 125 degrees is greater than what? 90 degrees. Is that right? Every one of these angles here are under 90 degrees. Okay, every angle here is under 90 degrees. So I want you guys to note something here. We have a situation. Knowledge is power. Let's note. We have the definition of an acute triangle and an obtuse triangle. Okay? Which triangle is this? Remember, the definition is going to be if you have an acute angle in a triangle, it's acute. Well, is it? I don't know. What's the definition? Do you guys know? Right? If you go, what's an acute triangle? What's an obtuse triangle? An acute triangle, ladies and gentlemen, is, what is it? Do you guys remember? Definition? For acute. All angles in the triangle, okay, are less than 90 degrees. These are what's called acute angles. Okay? All interior angles. So because you have 125 degrees here, you say, what's that definition? An obtuse triangle now, definition, one angle is what? Obtuse. So here, if you have one angle is greater than 90 degrees, and really less than 180, okay? You can't have an angle. If you're talking about a triangle, it's greater than 90 degrees. Sometimes book will say 90 degrees less than theta, less than 180 degrees, right? That's the definition of being an acute angle. Well, one angle is greater than that, 90 degrees. The triangle is acute. I'm sorry, obtuse. So you say, okay, they're talking about what? This is the one angle here, 125. So we have what's called an obtuse triangle. And those are just as valuable as any other triangles. Okay, so you have this obtuse triangle situation. What do you guys think? Right? This is still a triangle. But more importantly, what do you guys have? You have two angles that are adjacent, and you also have a what? Side. Okay? So I'm going to go and recolor and say to you guys, this is another example of what we call what? Side angle angle. Isn't that the kind of triangles we want to focus on this morning before we go to the third case? Okay, so we have these triangles here. Amazing, amazing thing. What's the game plan again? Always, if you have side angle angle, what's the game plan, ladies and gentlemen? Find the third angle. That's correct. Find the third angle. And that's easy to do because you got two angles. You guys see what I'm saying? So now you say, okay, 180 degrees minus 125 degrees minus 23 degrees, ladies and gentlemen. What do we know? What does that give us? Let's say, okay, TI, we get what? 180 minus what? 125 minus 23. What does that measure? It's 32 degrees. There we go. And now, what do you guys do? Anybody know? What do you guys do with this situation now? Anybody have an idea? What happens with this now? Should we say, what do? We're free to use now what? Law of what? Sines. Okay, what's the main piece of information we're going to use here? Did you guys see it? Yeah. And also, yeah, we're going to see what? Sine of 23 degrees over 15. Sine of 32 over A. Is that right? You guys okay with that? You guys see that there? Okay. We're going to use, again, the sine of what? 123 degrees over 15. Then that's going to equal sine of what? And we'll change it to green again. Sine of 125 over B. Okay, so we have now sine 125 degrees, sine of 25 degrees over B. What do we do with this now? We have to what? Cross multiply. You get A sine 123 degrees becomes 15 sine of 32 degrees. Okay, this is for finding A. Now for finding B, again, we're going to do cross multiplication. And by the algebra, you get sine 123 degrees times B is 15 sine of 25 degrees. Is it 125? Yeah. Only had 2 cups of coffee. What is it when coffee doesn't even help? I don't know. Adderall. All right. You gotta take some Adderall. So we got A and we got B here, right? Let's find what these values are. This is where the TI comes in. So double check. Did I screw it up? Is there? I don't think. No, there's a 23 degrees there. It's not 25. So yes, this will be what? 23. Okay. This will be 23. This would be 23. Okay. And I think this is sine of 125. Yes. Okay. So let's clean that up. I'm glad we didn't do any work yet. I'm glad we didn't get any answers yet. All right. All right, let's try to get that here. I'm going to clear this out. (15 sine 23 divided by sine of 125. What do you get for this value? What is A? Isn't that 7.2? Right, you guys see that there? Approximate to the tenths, 7.2. So here we go, 7.2, outstanding. And then B. (15 sine of what? 23 degrees divided by sine of 125. Wait a minute, did we screw up? What happened? I'm losing my mind. What happened? We're getting B. Let's see. Sine of 125 over B, right? What happened? Oh, wait a minute. This is all odd. Let me do it again. Where's the... All right. Sometimes you can talk too much. Sine 23 over 15. Okay, we're going to get B now, right? Sine 23 over 15. Now, isn't that sine 125 over B? All right, we're going to cross multiply. I think this is going to fix things. So we say sine 23 degrees times B is 15 sine 125 degrees. Well, now B will be what? 15 sine 125 degrees over sine 23 degrees. And here's my B. Okay, and I apologize if you haven't seen that. Let's look back. We're looking at this in green. So this is the green portion. And this was the purple portion. Okay, this is law of sines. So go back and take a look. Digest that a bit. So here we go for B. There we go. So B is approximately, what is this? 31.4. So over here we got 31.4 for B, so people know. And then what is A? A is what? I don't know. Did we make a mistake on that one? Is this okay for A? Let's double check A. A, we have sine of 23 over 15. We don't know. Let me double check. Is this supposed to be in purple? Is that right? Right? Let's double check. Are we in purple? Are we purple here, ladies and gentlemen? You guys see what I'm saying? Okay. And then A is what color? Orange. So it looks like there's this. So this should be A sine 23 degrees and 15 sine 32. So, okay. So this should be down here, what? 23. All right, let's see what A then becomes. So double check, does that look okay now? All right, let's see what happens here. Then you say 15 sine 32. Hard to see. Sine what? 23. So it is 20 point what? 20.3. Outstanding. Got to bring the bags of Flamin' Hots. Pass them out. So A is 20.3. Apologize. 20.3, 31.4. So this is 20.3. Okay, and we have solved our what? Triangle. We found every interior angle, every side. Solving a triangle. So remember how we started yesterday and how we started today? I said, what do we want to do? Right? Remember, this is a special situation, side angle. Very special. And you say, why is that? Because the problem with this situation is there's only one angle. There's not two angles. If there's two angles, we can very easily get the third angle. So there's a real situation for, this is a special situation. So I'm going to take this here. And I'm going to say, with this situation, we have three outcomes. There could be no solution, meaning there's no triangle that exists that satisfies that criteria. There can be what we call one solution. It's a unique solution. And then there can actually be two solutions. So what I want to really describe to you, this is what's known as the ambiguous case. And you say, why is it ambiguous? Because you could have no solutions, you can have one solution, you can have two solutions. Okay? So we're going to have to see some examples of this. Now, unfortunately, we started yesterday. There was technical difficulties. We crashed. Who knows what happened? And so we started that kind of problem, the ambiguous case. And what I'm going to do here again is we're going to look at this. from the beginning. And, I'm going to get rid of some of these things here. So I'm going to start completely from the what? Beginning. Because I don't even know how much of that was really what? Got through in the recording, or at least through the transmission. Okay, now, why is this side angle angle? What does that mean if it's side angle angle? Oh, is it side? It's not side angle angle, is it? Yeah, it is side angle angle. I think it's a different example. Where was it? No. Okay, that's weird. Oh, it's in the other. Yeah, we're going to make it up. Okay. So it's in the other, ladies and gentlemen. We're going to give you this example here. It's in the other sheet. Should we pick it out in the other sheet? What do you guys think? Maybe? Or we can make it up. Yeah, let's go back on that sheet. Here. No. Here. I think it was number 4. So I'm going to have to change some of this sheet here, just so you guys know. Okay. And, we can keep this stuff if you guys want. We can just keep it. Let me remark again. It might already be in your notes. Notice again. Let's go through this. This is known as a, you say, what's side angle? This means there's two what? Yeah, two adjacent sides. SS. So two adjacent sides, where are they? First, second. But then you have a what? Angle. So let you guys copy that down here for a second. And by law of sines, okay, you can say, is that sine 32 degrees over 8? Does that equal sine B over 10? And I'll say yes. Because again, notice you're going to take advantage of the excuse me, opposite side, opposite angle situation. Purple. Okay, and then here's what you must have. Even though this is not known, you got to have that known value down there. Do not use sine C over little c. You say, why shouldn't I use that? You got two unknowns, if I can. Don't use that. You have two unknowns. Okay? Here, those are unknown values. Those two unknowns. So you can solve an equation when there's only one unknown. You want only one unknown, ladies and gentlemen. Easy breezy lemon squeezy. You guys okay with that? Only one unknown. So, okay. Now, when you cross multiply, we started to do that yesterday. Yeah, we get 10 sine 32 over 8 will be sine B. When you actually solve this thing. And so, as we solved this yesterday, we get sine B is 10 sine 32 degrees over 8. And maybe I'll do that again. I'm going to focus on this arithmetic right in here. And just to illustrate today, 10 sine 32 divided by what? 8. And what do you get? We approximate that to the nearest tenths. Sine B is 0.7. Okay, that's what we did yesterday. We got that here. So again, what I'm saying to people is this. Once you get that value here, this was the value we got. That's not B, that's sine B. That's saying the sine of the angle is 0.7. Now notice, isn't that expected? Why should that be expected? Do you guys know? Here's a fact about sine of any angle. Isn't sine of any angle, this is how we formally write it. The absolute value is less than 1, which means sine lives between what? -1 and +1, okay? This is a big deal. That sine will live between these two values here, okay? So in other words, we know, okay, so far so good. But if I go back to my scratch sheet, with this ambiguous case, right? This is what I want to remind people. That if sine of B is 0.7, that's logical. I want you to understand this part because it's vital. Remember how we went through all the work with trying to graph sine, and the amplitude is between 1 and -1, and that period is between 0 and 2 pi, and right in the middle is pi, and the middle of that is pi over 2, and the middle of that is what? 3 pi over 2, and then we what? Remember sine being what? 0.7? Here's where 0.7 would be. Okay, you with me on that? This is the picture you guys want to actually always think about. Now, what do I say about this here? There's two angles. So you guys understand what I'm saying? They didn't restrict the domain for sine B. In fact, it's kind of naturally restricted from 0 to 2 pi, really. So in that sense, so what I'm saying is we need angle B1 and we need angle what? B2. So there's possibly two angles for B, okay? All right, you guys see what I'm saying? And I'm going to point this out too, so you guys understand. This is important. But I don't know what colors to use. I'll use pink. B1 is between 0 and pi over 2. That means B1 is in quadrant 1. Is that true? And then what other color? Maybe purple. B2 is in what quadrant? If it's between 90 degrees and 180. Isn't that quadrant 2? So what I'm saying is you have quadrant 1 solutions and you have a potential, well, you have a solution in quadrant 1. You have a solution to this equation in quadrant 2. That's what's really important to know. Okay? Now, the real question is going to be, this is what you have to answer. What is angle B? You're going to use B equal to the inverse sine of 0.7, okay? This is what you guys use to answer the question. Now, we'll talk about in great detail the inverse sine key, but some of you guys may already know from intermediate algebra about inverse functions. But we study this in this, not now, we don't study the detail here. So in other words, we're going to find where inverse sine is 0.7, okay? So you say, how do I do that? Well, I'm going to have to scroll out a little bit and see if I can see things. clear that out. Do you guys see where inverse sine is? Where's inverse sine? See if you guys can see that here. You might not see it here. It's blue. It's above the sine key and in blue. So I have to hit second sine because it's blue. Now you have inverse sine. Inverse sine of 0.7. Close that here, ladies and gentlemen. What do you get? What's this angle? That's going to give you what you're looking for. See that inverse sine down there in blue? That's how you do the second key. Let's go out to the nearest tenths here again. What angle is that? 44.4 degrees, ladies and gentlemen. You're using the inverse sine key. Okay? This is doable. We'll get to some detail about this. Now that's quadrant what? 1. In other words, we say B1 is what? 44.4 degrees. We also have the quadrant 2 solution. Does anybody want to know? How do we go about that? Right? Maybe we should go to all students take calculus. What? What? Oh, there we go. How did I lose my photos? There we go. All students. I think I'm looking for, which one am I looking for? All right, we'll look for this one. How's that? Okay. Here's what I'm saying to you. We found B1 to be what? 44.4 degrees. Is that true? Remember, sine of B is positive. What does this mean? Well, one solution's in quadrant 1, the other one is in quadrant 2. Do you guys remember that? This means this is also over here what? This reference angle is 44.4 degrees. So you're looking for, ladies and gentlemen, this angle. This is my B2. How do you guys get B2? What's the moral of the story? B2 will always be what? 180 minus B1, because this is my quadrant 1 angle. This is the reference angle for quadrant 2. This is where sine's positive. Remember that? All students take calculus. So if you said, do I get B2 now by using this relationship? Yes. Always, always what? Always. Okay, I'm explaining to you how to get that B2. So you take 180 minus what? 44.4. And ladies and gentlemen, what is this? What? 6 degrees. Okay? So here's your two solutions for B. So all of this in the ambiguous case. But don't worry, follow your process, okay? So now you might say, well, what do? I'm going to go back over. No, I don't want to do that. Okay, I want to go back to the right sheet. I don't even know what sheet I'm on anymore. What do we do now? So let me erase some things, okay? So all of this when you have that situation. Okay? So we have two B values. What were the B values? B1, 44.4. What about this? What was B2? Okay, so this is what you guys need to do now. I'm going to erase this stuff. You got to see if this makes sense. You say, what do you mean? Well, you see this B1 triangle? They're saying this is 44.1 degrees. Okay. So far, so good? 44.4 degrees. Okay. Now, here's what I'm going to say. Does this make sense? How do you know if it really makes sense? Go over here. 180 minus 32 degrees minus what? In other words, if you can get angle C to make sense, well, then that's a solution, okay? So I want to answer, does this make sense? Well, let's see. 180 minus 32 minus 44.4. I think I forgot the 0.4. Okay. Now, you say, what is this? This measures how much? 103.6 degrees. Now, does that make sense? The answer is what? Yes. Although the picture doesn't make sense, okay? Because that's not a what? An obtuse angle situation. But numerically, this makes sense. So sometimes this happens on pictures, ladies and gentlemen, okay? You got to get used to that idea. So just think about this. The picture is not an obtuse triangle. It's acute, but numerically, does this make sense numerically? The answer is yes. Okay? Now, I want you guys to note. Let's try B2. Does B2 make sense? Well, how would we know if B2 makes sense? You go back again, and what do? You do all this again. And just remember what that angle is, 103.6? So you would do this all again. You'd say, okay, does this make sense? If B2 is 135.6, find angle C minus 44.5 minus what? 135.6. Okay, you with me on that one? Let's see if this makes sense. 180 minus 44.4 minus, what is this? 135.6. And you get what? 0 degrees. Is that true? Well, you do this again. Oh, I think I made a mistake. Sorry. Let's do it again. What do we do here? Oops. Well, let's see. What are we trying to say? We're trying to say now that this angle here, let's go back. We're going to do the purple angle. We're going to say 135 point what? 6 degrees. So let's see if this makes sense. This is what we're saying. 180 minus 32 minus what? 135.6. Okay? There we go. Now we're good. 180 minus what? 32 minus 135.6. And what does that equal? 12.4 degrees. Okay, now here's what I'm going to say again to you guys. The picture may not make any sense, but when we ask this question numerically, does this make sense? The answer is yes. Now you might say, what does that mean if both of the B values make sense? You know what this means? There's two solutions. That's what this means. There's two solutions. Yes? Yeah, there's no 0 degree angle. Yeah. So it was, yes. But, I mean, here's essentially the situation. You might have two solutions. And how do you know? Both B values make sense. they give you a legitimate C value, meaning both B angles make sense. They give you a legitimate C angle. In both cases, that means two solutions. So sometimes what you'll see is that there's two solutions, not just one. But that's only going to be for the side-side angle, the ambiguous case. Now, you might have only one solution, and we'll see examples of that. And you might have no solutions. We'll see an example of that too. So you might say, well, what do I do? Well, what you do here now is you actually solve both of them. You now have two questions. So, I mean, and then I'm going to have you guys help me in this because old man judge. Let's try to do it here since I don't have to try to memorize all these things. I used to be able to memorize everything instantly. But, you know. Okay, so let's try this with B2, okay? Since we're on the topic of B2, that's our first one. We're going to go back to B1. So far, this makes sense. Now, what do you do now? Law of sines. So, okay, what's law of sines? Well, sine of what? That first B value, 135.6 over 10. Is that right? That's our purple. Okay, so far so good. What do you guys need? What do you guys need? Don't you need what? Little c? Don't you have the angle 12.4? You guys see what I'm saying? So we have the opposite situation. Sine of what was that? 12.4 degrees. That's the orange. Over little c. So how do we get this again? By what? Cross multiplication. So okay, let's punch this in. Tan times sine of what? 12.4 degrees divided by sine of what? 35.6 degrees. So what do you get for little c? Go out to the tenths. Isn't this 3.1? Ladies and gentlemen? Okay, 3.1, so little c is 3.1. And notice what you guys did. You solved the what? You solved that triangle. But that's only one solution. You have two solutions. It's an ambiguous case. So what do you think we do to get the other solution? Do you guys remember? Yeah, you got to use, you're going to have a different B value. The first B value right in here, that's B1, right? And then what do we get here? Do you guys remember what we got here when we found the angle C? What do we get? Well, it's 180 minus 32 minus the 44.1 or 44.4. What did you get for C? 103.6. Okay. So this is going to be the second solution or the first solution of the second solution. Yikes. And that's how you solve the triangle, right? We're going to do this now. So it's sine of 103.6 now. Because you still, let's double check here. Well, it's not. Let me double check. Let's write it all down, okay? Let's not try to get ahead of ourselves. So let's see what law of sine says. Law of sine says what? Sine of 44.4 over 10. Is that right? Because we have a different B1. Sine 44.4 degrees over that 10 will equal sine of what? 103.6 degrees over C. C sine 44.4 will equal what? 10 sine 103.6. So what is C? All right, you guys okay with that? So what do you guys do now? You want to punch this in the what? The TI calculator, and then you're going to get the second solution, okay? So let's try that out, and you go, okay, 10 sine 103.6, close that, divided by sine of what? 44 degrees, okay? Now what do you get here? This is about, to the nearest tenths, that's about 14. Okay, so we got about 14 there. So ladies and gentlemen, change this to what? 14. There it is. Yes. No. Shouldn't matter. Okay. It shouldn't matter. Okay, good question. But, you know, this is the ambiguous case where you can have two solutions, in which case you got two triangles to give as answers. And I know I went through the details here because there's not a lot of space, but that's kind of what to expect. Okay, now let me show you guys the situation where there's no solution. Okay, so to do that, I got to go to my trusty notes, because, you know, making it up randomly, you're not going to be able to necessarily do that, you know, because there's special situations. So anyway, let's go back here if we can. So let me give you an example, ladies and gentlemen, where there's actually no solutions, not, you know, two. If we can get that. Okay. Okay, I found one. Okay, so you might say, hey, what does that look like? Well, let's find our scratch. All right, so now you might say, hey, what does a no solution look like? So we have angle, vertex A, or angle A, vertex B, and so on, okay? So you can have 50 degrees, 100, or 50, sorry. I'm blind. $100. Now, How do we know this is the ambiguous case? What do we have? Side, side. Aren't they adjacent? Then you have angle. Okay, ambiguous case. What am I saying here? What does it mean to have an ambiguous case? What is that meaning? It means you can have either what? No solution, one solution, or what? Two solutions. That's the meaning. Side angle is called the ambiguous case. If you get drunk this weekend and you get a tattoo, you might end up with a side angle ambiguous case tattoo because you never know. You're drunk. You guys know what I'm saying? You might come home with that. But make sure you put ambiguous case next to it. I'd say, no, Mr. Judge, I'm not going to get drunk and get a trigonometry tattoo. You never know. Has anybody, I guess you guys are probably young, huh? Anybody here gotten drunk and gotten a tattoo? Okay, does anybody know anybody who's gotten drunk and came home with a tattoo? Okay, so it happens, okay? So why not a math tattoo? Get the ambiguous case, side angle. Remember, what's the problem? You only have one angle. So what do? If we try to apply the law of sines, you start with the law of sines here. By the way, what tattoo did they get? I'm just curious. They got an ex-girlfriend's name? Oh, my God. Oh, that's sad. Oh, one of those, huh? Oh, my God. I'm going to give you guys some relationship advice. This comes straight from Mr. Judge. You get everything here. You get study advice and trigonometry. I'll give you some relationship advice. Never obsess over an ex. Never obsess over an ex. You guys know why? I'm sure they're not obsessing over you. You guys. So return the favor. In other words, move on. That's the best advice I could ever give any of you guys. Because there are people who will obsess over that. Oh, I wonder what she's doing. It's like, dude, don't even worry about it. It's done. Move on. You'll find somebody better. I guarantee you. And do girls obsess over their exes? What would I say to a daughter who's obsessing? Move on. If he wants to be here, he'd be here. He's not here. Move on. You'll find somebody what? Better. There's always somebody better. Not sometimes, but what? Always. And that's what young people don't know. I'm going to leave my tip jar here. Like if this was Starbucks, you guys could drop off your tips on the way out. Okay, you guys know what I mean? You'll get some relationship advice. Woo! Oh, yes. What is this? These are opposite. What's this? Sine C over 100. So again, you have to find another angle because you only have one angle. And you're going to use law of sines to do that. So remember, this is kind of easy in the sense that you really don't have to cross multiply, do you? Multiply both sides by 100. Huh? Yeah, he multiplied both sides by 100. Sine C is 100 times sine 50 degrees over 50. Or sine C will be what? 2 sine 50 degrees. So So you might say, well, okay, what do we do now? What did we do before? Do you remember? Didn't we what? We have to determine what 2 sine 50 is. So in the TI, you say 2 what? Sine 50. And what do you get? 1 point. We're going to approximate that. That's approximately what? 1.5. Is that true? Okay. Does anybody know what's the problem with this? It's greater than 1. In other words, this is what? Impossible. Is that true? You say, why is it impossible? What was the fact I gave you guys? Is it still here? Remember, what does sines have to live between? Oh, I think it's on the other sheet. I got rid of it. Whatever. Horrible. I'm going to write it again. The absolute value of sine of any angle is less than or equal to 1, which means negative 1 is less than or equal to sine of an angle, which is less than or equal to 1. So that's impossible. So if you say, but Mr. Judge, if I can't find an angle C and it's impossible, what does that mean about this triangle? It means there's what? No solution. Move on. Move on from this triangle like if it was an X. Yes. Yeah, you can't put anything else. It's a no solution. Yeah, absolutely. So why don't you guys compare and contrast that there are situations where you have no solution, 1 solution, 2 solutions for the what? Ambiguous case. And now you might say, what about the 1 solution? When do you know when then there's 1 solution? Well, I'll give you an example. It's really where only B1 works and not B2. Yeah. So as an example, again, you have to have the ambiguous case. Because this only applies to what case? Side angle, angle, the ambiguous case. It only applies to that. Okay, so I'm going to give you guys an example where there's only 1 solution now. 67 degrees is given. 80, 56. Now you say side, angle, the ambiguous case. So you can start this by saying sine of 67 degrees over 80 is the same as sine of B over what? 56. So far, so good? That's by the law of sines. Now, what that means is that sine of B will be 56 times sine of what? 67 over 80. Okay? We're going to have to find the value of sine of B again, just like what we did before. Punch that in the calculator. Okay? So double check. We're doing law of sines for, again, this ambiguous case. Let's see. 56 times sine of what? 67 divided by sine of 80. What do we get? Oh, what did I do? I made a mistake. Let's try it again. 56 times sine of what? 67. Divided by 80, not sine of 80. We get point what? This is 0.64. We'll say 0.6. We'll go to the nearest tenths here, okay? So what you guys found is that number in gray. Now, what do you have to use again? Inverse sine of that number, 0.6. Okay, this is the key. So I'm going to scroll out so you guys can find that inverse sine key. It's at the bottom there. And look at this. I'm going to be so exact. Oh, okay. Inverse sine of 0.6. And what does that say? 36 point what? 9. So let's write down what this means. This really means that B1 is what? 36.9 degrees. Is that true? Now, you might say, why? Well, if I have to go through the detail again, there's two solutions. Remember that 0.6 out here? This is now not 0.7. This is what? 0.6. We got two solutions for B again. One is in quadrant 1. The other is quadrant 2. We can very easily get what? How do you get B2? It's 180 degrees minus B1. Remember that? So remember this. This is another tattoo. So what is B2 going to be? 180 minus what? 36.9. And we get 143.1. And we colored that purple, I believe. Okay. So now you might say, oh, Mr. Judge, okay, we got the B1 and B2. But remember, you go back to the triangle, and what do you have to do? Ask if it makes sense numerically, not by the picture. So if B1 is 36.9, you guys see that there? We're going to say, okay, 36.9 degrees. Can we get A now? Yes, we can. Now we can say what? 180 minus 67 minus 36.9. Okay, now what does that equal? 180 minus what? 67 minus 36 point what? 9. You get what? 76.1 degrees. Now, again, does it make sense in terms of the picture? Probably not, because you're not really measuring these angles, but it makes sense numerically. So guess what? That's so far one solution. How do I know that there's only one solution? Well, do the process again. What do you know? What is this going to be now? Is that 143 point what? 1? So we're going to get angle A. And sure enough, what do you guys notice? You get what? 180 minus 67 degrees minus 143.1 degrees. I already can tell that doesn't make sense numerically, because you're taking 180 minus like 200 degrees. You guys know what I'm saying? So this time you say, oh, 180 minus 67 minus 143.1 degrees. And ladies and gentlemen, you get a negative 30 degree angle. No, that makes no sense. Moral of the story, there's what? One solution. So throw this madness here out. You don't say, hey, there's one solution. you have to solve the triangle. You guys know what I'm saying? This is 36.9 degrees. What do we get earlier for angle A? What is it? Okay. So this is the only solution. You just need to get now little a. Okay? And that's how we use what? Or that's how we handle the, what is this called? Look at your tattoo. What do we call that? The ambiguous what? Case. Ex-girlfriend's name on the tattoo. Jeez, really? Okay, let's try to finish this off, right? We want a solution. Students like finishing problems. They hate when you don't. What did I just do? Okay. And then what do we have? Sign of what? Sorry, I got to get my water out. A is what? If you solve for A by cross multiplying, you're going to get this. Okay. Let's see what A is. $80 sine of what? 76.1 divided by sine of what? 67. You now get what? 84.3. So 84.3 for A. This is considered the what? One solution, ladies and gentlemen, example for your ambiguous case. This only happens for the ambiguous case. Side angle, you can have no solutions, you can have one solution, or you can have what? Two. Okay? And there lies the what? The lesson for law of sines, okay? All right, so I'm going to give you guys homework in Canvas from the book. And we'll see you guys when? What's today? Today's Thursday already? I don't even know the day of the week. I'm always a day behind. I still think it's Wednesday. Well, I mean, so what I'm going to encourage you guys to do, I'm going to send you guys out so you guys know a survey. I want to survey you guys and see what you think. I'm going to make it extra credit, so I got to figure out how to do that. And, you know, I'm going to send you that survey. And I'm also going to encourage you guys, when do you want to get to your law of science homework? Today. It means everything. I'm going to play a Van Halen song called Right Now. Because it means what? Everything. All right. See you guys later. Have a great weekend.